All right, I got good news and I got bad news. Good news is that we're not going to be on the unit circle for a little bit. Okay? All right? Bad news is we got to do navigation. Okay? And navigation is tricky. Okay? Right? It's tricky because it's a totally different style of thinking. Okay? All right? So, how many ways can we name an angle? We're going to name it at least 3 ways today. Okay? All right, so here we go. All the angles in navigation are measured from the north. Okay? North is up, is at the top. Okay? So 0 is now at the top, up, not out to the right. Okay? Positive navigational angles are drawn clockwise. So, what that means is north, south, west, and east. Okay? So that means that north is 0 degrees. East is 90 degrees. South is 180 degrees, and west is 270 degrees. Okay? Now, with that being said, now let's get all cray-cray. I don't even know why this is up here. Oh, that's why it's up there. Let's put it back then. Okay? So, 53 degrees. Okay? So 53 degrees is going to be here. Now. Right? In terms of a reference angle, that would be a 37-degree reference or trig angle. Right? So it's different thinking. Okay? We got to start up top. That's where 0 is. Okay? 195. 195-degree in terms of navigation is down here. It has a 75-degree reference angle. It has a what's 180 plus? What's that? 265? No. 255. It's got a 255-degree trig angle.
Why'd you draw it from the 90 degrees?
Because trig starts with 0 at straight out to the right.
Oh.
There's all 3 different ways to name the same angle. Orange is navigation. Blue is reference. Green is trig.
Okay.
Okay? Depends on what we're doing with it as to what we're going to use.
Makes sense.
Yeah? All right? Find me where the navigation angle is, what the reference angle is, and what the trig angle is for those two. So navigation-wise, 300 degrees would be here. That would also then be a 30-degree reference. Just forgot to put that it goes that way.
Is it always from this?
What? Reference angles are always off the horizontal. Yeah. Always. Just like Walmart. That gives me a 150-degree trig angle. Agree? $127 would be down here for my navigation, which then that would give me a 37-degree reference, which would give me 323-degree trig. Yep. Okay. Questions on that? Now, reason that we have to go through naming all those different ones is because we're going to put it to work. We're going to use this stuff. Okay? So on the back side should be some word problems, or on the next page should be some word problems. Okay? So a speedboat travels at a speed of 40 knots from Fort Lauderdale on a course of 65 degrees for 2 hours. Okay? So that part, we'll say that port is, we'll go blue, 40 knots from Fort Lauderdale on a course of 65 degrees for 2 hours. So 65, in my brain, I'm thinking to myself, 65 degrees is there, right? Because this angle here, can I go a little thinner? This angle here is 65 degrees. It traveled along that path for how long? For 2 hours, right? So how far did it go? Oh, I'm not there yet. I'm still in 40 knots. You just haven't gone too far yet. With me? So how far did it travel? If it's traveling, thank you. That was the easy question so far. How far did it travel? It's traveling at 40 knots for 2 hours. far did it go? 80 knots. Okay? Do you guys even know what a knot is?
No.
It's a nautical mile. Okay? Okay? It's a nautical mile. Okay? Then it changes its course to 155 degrees. For 4 hours. So now 155 degrees would be down there, where this is 155 degrees. How far does it travel along the red? 160 nautical miles. They are different, just so you know. We want to determine the distance and the bearing from Fort Lauderdale. Okay. Well, let's figure out stuff that we know. What is this purple angle right in there? It's not the complete angle of the triangle, but it's close. That's 65 because of parallel lines. That's alternate interior angles. So that one's 65. What is this purple angle? 25? 25? So altogether, what is this angle there? How much? It's 90. See how I did that? Okay. That helps us out immensely. Because now what kind of a triangle do we have? We got a right triangle. So how can I find this distance? Pythagorean theorem. Okay. So what is 80 squared plus 160 squared? And then square rooted. What we got?
178.88 or 89.
So it's 178.89 nautical miles away from Fort Lauderdale. Okay. Now we got to find the bearing. Which angle, you can describe it by the color of the sides, which angle do we need to find? Blue and maroon or red and maroon? This angle, do we got to find this angle or this angle to find its bearing? What? Blue and maroon. We're going to find this one up here, yep. Oops.
What's the definition for bearing?
Navigation. So we got to find the angle to get to it. Okay. How are we going to find that angle? How are we going to find that angle? What am I going to use? What? Don't need to use law of sines. I got a right triangle.
Use like alternating exterior angles or whatever?
Nope.
You could use sine of 80 over the hypotenuse that we just found.
80 is a side length, though.
Oh, it is. I mean, couldn't you like put that over 178 and like the sine of that value would give you an angle?
I wouldn't even need to. No, sine's going to give me a number. Inverse sine gives me an angle.
Okay, yeah, that would work.
It's not a 45-45 triangle, though. Okay? Nope. You guys are thinking about this way too difficult. Inverse tangent. Why am I going to use inverse tangent, KB?
Because you have an opposite and adjacent angle.
Actually, I don't want to use X. Let's call it Y. So the tangent of angle Y is going to be what? 160 over 80. TOA. What's 160 divided by 80? 2. So Y, in terms of degrees, is going to be the inverse tangent of 2. What do we get? 63 point. Right? And that's my yellow angle, correct? So what is the bearing to the boat? No. Navigation comes off of where? Where does navigation come off of? Where's 0 for navigation? Ah.
Plus 65.
Right. Yep. So I start up here. I got to get 65. Then I got to go 63.4 more, right? So what is my navigation angle to the boat from Fort Lauderdale?
128.4 degrees.
Where'd it go? Down. There it is. I don't know when, but soon we're going to add in a different style of angle too. Okay? Where we're going to say north 38 degrees east. Okay? So then you would go 38 degrees east of north, and that would be your angle. Okay? Okay? So there's multiple ways of doing these. Okay? Let's go through a shoreline running north and south. Okay? So a shoreline runs north and south, and a boat is due west of the shoreline. So a boat is due west of the shoreline. The bearings of the boat from 2 points 300 feet apart. So here's my first point, here's my second point, and this distance here is 300 feet. Our 240, so my red angle here is 240. So 0, 180, 240 puts this as a 60-degree angle. Do we agree with that? Agree? That angle, that red-yellow angle is 60 degrees. So if I'm sitting up here, this is 0, right, Morgan? Right? So 240, 90, 180, 240 would be down here. If 180 is down here, that leaves this part in there as 60. What's my blue-black angle? Do we agree with 80 degrees? Do we agree with 80 there? Zero, 180. I got to get out here to 260 degrees. That means that this has to be 80 degrees in there, correct? Okay. How far is the boat from shore? So we want to know that distance. Do we have right triangles? Yes, that helps. It helps if you work in right triangles. So if I'm looking at the red right triangle, this is my right angle here. This is what I'm trying to find. This angle up here is 60 degrees, and this side is y plus 300. Because I don't know what this distance is right here. If I look at my blue triangle, this is now 80 degrees, this is x, and this is y. and this is my right angle. So I would know that the tangent of 80 degrees is equal to x divided by y. Yes? From my red triangle, I know that. Yes? Yes? Mathematically speaking, tell me what I can do now. Set the x is equal to each other? Then get x equals x. Ian?
Yes, well, I was gonna say, like, make a system of equations, fine.
Don't even need to make a system of equations. I already got a system of equations.
Oh, cool. So just, isolate the x and have like,
We did isolate the x already.
oh yeah, so just like y tan 80 equals y plus 360.
So set the other parts equal. So substitute y times the tangent of 80 in for x. Is that what you were trying to say? Okay, that's what I figured you were trying to say, but I'm like, she might think that x does equal x, which it does.
Yeah.
Okay, yep, but okay, yep. So let's go with, so y times the tangent of 80 degrees is going to equal y plus 300. Are you guys okay if I just distribute this in right away? Can I distribute? So y tangent of 60 plus 300 tangent of 60. Yes? Now what? Why did I do that? Y's are on the same side now. What did I do there?
Can we skip that step?
What?
Can we skip that step?
No. No. Because we don't know what y is. So what's y? So what's y? Be careful how you're typing it in. Make sure you're closing all your parentheses. Make sure you close your parentheses. Okay? Then, because I'm running low on time here, I'm actually over time already. Then, to find x, I just have to put that back in to the to this equation up here, that blue equation. So I have to multiply that by the tangent of 80, and I get that the boat is 748.086 feet off of shore.